Alright, so for numbers 1 through 5, it uses the congruent statement at the top here. So it says triangle YZA is congruent to triangle CBA. So you look at number 1, it says angle Y. So if you look at where Y is first in the order for the first triangle. So Y corresponds to the first letter of the second triangle. So that would be angle C. So angle C. So once again, Y is first, so you're looking for the first letter there. Alright, so then number 2 says side YA. Well, Y is first, A is last, so I'm just looking for first and last in the second triangle. So that's segment or side CA. Then the order in the next one is angle ZAY. So ZAY goes from the middle to the first, then to the last. No, that's not right. Let's correct that. Let me erase all this. ZAY is the middle, then the last, then the first. So middle, last, first. So when I come over to the second one, it's middle, then the last, then the first. So that's angle, middle was B, last is A, first is C. So just make sure your order is corresponding with the other triangle. So for number 4, this is actually using the corresponding parts now. So basically apply what you know. So it's nothing new, it's just basic algebra and applying what you know. So we know that YZ, side YZ, which is first and middle. And if YZ is the first and middle, and you look at what you have here, which is CB, you notice that's also the first and middle. So we know that those are corresponding parts. And one thing we should know by now is that corresponding parts of congruent triangles are congruent. So basically they're equal in length and measure depending on, what we're talking about. In this case, we're talking about sides of the triangle. So basically the sides of those two triangles are congruent. And congruent, remember another word for congruent is equal. So these two things or expressions are going to be set equal to one another. And then we could solve it. It's just an equation from that point. So I'm going to do it out here to the side. So we have 36 should equal the same thing as 8x plus 12 because they're corresponding parts. So remember, anytime you find corresponding parts, you can set them equal to each other because they should be congruent. So from here, we're just solving for x. And remember, x is here. So we basically need to move everything off of the right side of the equal sign and get it over to the left. So in order to do that, we have to undo what's being done. So basic algebra says we need to go ahead and do addition or subtraction first, undo it. So remember, you're undoing PEMDAS when you're solving equations. So now we have 36 minus 12, and that's 24, equals, I'm going to bring down my 8x, because we didn't do anything with it, so we got to bring it down. That's just a terrible arrow. Alright, so now we can go ahead and undo the 8 there by dividing. And so now we have x by itself, and we have it equal to, that equals 3. So x is equal to 3. And that's all you had to find for this problem. It says x equals what? Well, x equals 3. So anytime you find corresponding parts, set their expressions equal to each other and solve. So number 5, it says if the measure of angle B, well, angle B, we got to go ahead and look at our congruent statement up here. I erased some of number 1, but we already did it, so it doesn't matter. So angle B is in the middle. And the measure of angle Z, well, angle Z is also in the middle. So right there, we know we have corresponding parts, so we can set those two expressions equal to one another. So 2x plus 11 equals 3x minus 7. And then now, we're going to use our algebra skills to solve that. So remember, it's best to get the variables together first, and it's always best to bring the smaller one to the bigger one so that you don't have to deal with negative numbers or a negative variable. So basically, that's gone, and now we have 11 equals 1x, because 3x minus 2x is 1x, minus 7. So I'm going to bring this up here. It's my terrible arrow again. That way I can work under it. So 11 equals 1x minus 7. Alright, so now we're going to add 7 to both sides because we want to get it away from the x. And so 11 plus 7 is 18. Remember, 1x is the same thing as just x. So I don't really need the 1 in front of it. So we know x is 18. Now, in geometry especially, always look back and see if you answer the question. Because they didn't just ask us to find x, they actually asked us to find the measure of angle B and angle Z. Now remember, B and Z are corresponding parts. So once we know one of them, we know the other. So we're going to take our 18 that we just found and we're going to put it in for x. So that's really 2 times 18 plus 11. Well, 2 times 18 is 36. 36 plus 11 is 47. So this equals 47. And remember, B and Z are corresponding, so we should get the same thing if we put x into Z. So 3 times 18 minus 7. 3 times 18 is 54 minus 7. That does give us 47. So notice either way we get 47 as the measures for angle B and angle Z. So 47 degrees. Alright, so moving along to number 6. So number 6 and 7, let me erase some of this so I can see the problem. 6 and 7 use the same information. They use the diagram on the right. So it says in the diagram to the right, if triangle JMK is congruent to PRQ and JM is equal to 6x plus 2, PR is equal to 14, and JK equals 9x plus 12. Find the length of PQ. So here we have lots of different corresponding sides. So we need to go ahead and match them up, see which ones actually correspond. So JM. We know JM in the picture is here. That side corresponds, well, if we look at the picture or look at the congruent statement, JM is congruent to PR. So those two I could set equal to each other. So JM and PR, those are congruent. So I could set those equal to each other to make 6x plus 2 equals 14, and I could solve for x. So if we do that, subtract 2 from both sides, so 6x equals 12, and then divide by 6. We have that x is equal to 2. Now once again, the problem doesn't just ask us to find x, it asks us to find PQ. So PQ in the picture, I'm going to just make this green so I can mark it in the picture. PQ is here. PQ corresponds to JK. So notice, if we find what JK equals, which is 9x plus 12 right now, if we find what that equals, because it corresponds to PQ, we'll also know PQ, which is what we want. So PQ is the same as JK, and JK equals 9x plus 12. But guess what? We now know x. So x is 2, so we could replace x with 2. It's a terrible replacement, but I didn't want to erase. So 9 times 2 is 18. 18 plus 12 equals 30. So now I know that the length of PQ is 30 because JK is 30. So if JK is 30, so is PQ. So the answer to the overall question is that PQ equals 30. And it doesn't tell us whether it's inches or centimeters, so we could just leave it as 30. Alright, so now number 7, it tells us the measure of angle P is 32. So I'm going to erase what I have marked here so I can actually use the triangles again, because now we're talking about angles. So angle P is 32 degrees, so remember when you get information to go ahead and label it. The measure of angle M is 122. And the measure of angle K is 3x minus 1. So now I can use the whole corresponding idea to fill in some of these blanks. So for instance, 32 is also going to be here. And 122 is also going to be here. Well, we should know that the measure of any triangle, the angles in any triangle should add up to 180. So the degrees in a triangle should add up to 180. So I should be able to find that angle right there. So if I do 32 plus 122, so 122 plus 32, I get 154. Well, I need to subtract that from 180 in order to get how much should be in that other corner that we're missing. So I get 26. So 26 is the measure of that angle. So I'm now going to erase my little question mark, and I'm going to put the 26 right in that corner. Now, does that answer our question? No, because in the end we want to know what x equals, because that's what we're asked. But we can use that. We know that that angle right there is 26 degrees. Well, then this angle over here must also measure 26 degrees. Now we know what 3x minus 1 has to equal. It has to equal the 26 degrees that is in that corner, or that angle. So now we can go ahead and solve, and we get 3x equals 27. Once you divide both sides by 3, we get that x is equal to 9. So now we found x. So it's all about using what you know. Everything there is just applied information. You know what corresponding angles. You should know that a triangle measures 180, or the angle measures add up to 180. And you should also know how to set up the equation when you know what the angle should equal. Alright, so for this next section, we're writing the congruent statement for each pair of triangles. So basically, we know that the two triangles are congruent because it doesn't tell us here to figure out what they're congruent by on number 8. So I'm just looking at the order. RAC, notice R is here. Then it goes to A. Well, A goes across this 3 tick mark side. That was definitely 4, but 3 tick mark side. And then it goes to C, which is across the 1 tick mark side. So you got to make sure you go in the same exact order when you do it on the next triangle. So remember, we're going across the 3 tick mark side first, then the 1 tick mark side. So here's the 3 tick mark side. You can either go that way or you can go that way. Only one way will send you across the 3 tick marks and then across the 1. So we have to start at O to go across the 3 tick mark side, then across the 1. So we're going O, P, G. So O, P, G. So use the markings to your advantage to know what direction or order you're going in. Alright, and it doesn't tell us to say what postulate, but there is a postulate for that one. Alright, so number 9, FOX. So it's starting in the second triangle here. F is with the 3 angle marks. So we're starting at the 3 angle marks. So I know I'm starting at B for the second one. Then FOX, so F to O, then goes to the 1 angle mark. So in my corresponding triangle, I need to go to the 1 angle mark. And then so FOX. Then it ends at the 2 angle mark. So that'd be O in that corresponding triangle. Alright, the next one, GHI. So starting at G, going to H, so going to the middle, and then going to I. So notice we're ending at the marked angle. We're starting at the blank angle. So starting at the blank angle would be C, going to the middle, and then ending at the marked angle. So C, H, F. Now this one actually asks to name a postulate. So to name the postulate, let's look at the marks that we have already given to us. And it looks like we have an angle mark and we have a side marks. So we have a pair of angles and a pair of corresponding sides. Now remember, in order to mark something yourself, you have to have a reason for marking it. And you should be very familiar now with vertical angles. So hopefully Beatrice is out there saying, yes, I know what vertical angles are. Alright, so basically we know vertical angles and we now have another pair of angles. So this is the postulate angle, angle, side. Some of you guys are still like, well, how come it's not angle, side, angle? Remember, to be angle, side, angle, the S has to be in the middle, and this is not the marked side in between the two A's. It's not there, no marking. So it's not angle, side, angle. Instead, it's angle, angle, side. So angle, angle, side. And I should probably put that on the right line. There we go. So for number 11, it's ordered A, B, D. So A to B to D. So starting at A, going to B, so going across the center, and then to D, which is down. So I go from A across the center and then down the 2 arrows. So now if I look at this next triangle, I know I need to go across the center, but I need to end going across the 2 arrows. So if I went this way, I'd have to go across the 1 arrow. So I don't want to go that way. I need to go across the center, then across the 2 arrows. So that would be my order. Starting at B, going to A, then going to C. So B, nope, I should probably put triangle because I didn't put the triangle for us there. So triangle, B, A, C. Alright, so now it's asking what postulate. So remember, parallel markings are the arrows. It's telling us we have parallel sides. That does not mean that those sides are congruent. So don't assume that the sides are congruent just because you see arrows. This does not mean you can put tick marks. No, 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 no. Don't do that. Some of y'all are still doing that. So parallel and congruent, 2 different things. You could have parallel lines that aren't congruent. Those 2 are parallel lines, but they're not necessarily the same length. So that's just an example. Alright, so whenever you have parallel lines, though, you should know you have alternate interior angles. So for instance, these 2 sides are parallel. So if you have this line that's intersecting your parallel lines, you have alternate interior angles. So anytime you have parallel lines, you have alternate interior angles. So I have another pair of parallel lines here. I'm going to make them red. And the same thing, when we have the parallel lines, the 2 red lines cut by this center line here, then we have a pair of alternate interior angles. So no matter how you look at it, we have 2 pair of alternate interior angles. Then we also have our reflexive property we can use, that one side is congruent to itself. So right now you should see that you have a pair of angles, a pair of sides, and a pair of angles. So that's angle, side, angle. Make sure you guys are doing the actual, or putting the actual marks on the triangles. Alright, so number 12, CAB, so cab. Oh, I actually had to fix the letters here. So if you notice on your sheet, this probably says D, and this probably says A. So you actually need to switch those. So just cross them out. I already switched it. That's why my letters are different from yours. Oops. So make sure you go ahead and scratch it out. Fix it on your paper. It was a typo. Alright, so anyways, CAB. So from C to A to B. So basically we're starting at the corner, going to the right angle, and then going to the 2 angle marks. So starting at the corner, going to the right angle, and then going to the 2 angle marks. So that's D, A, B. So triangle, D, A, B. Alright, and then what is it by? Well, let's look what we have. We have a right angle. Remember, just because you have a right angle doesn't mean you have a hypotenuse leg. Hypotenuse leg would have to be, okay, I have that side marked, which you don't. No marking there, so you don't have hypotenuse leg right away. And you'd have to have some other leg marked. So you don't have hypotenuse marked, so it ain't hypotenuse leg. But what we do have is we do have a pair of angles. No matter what, 90-degree angles are, all 90-degree angles are congruent, so we have this pair here. Alright, so we also have a pair of angles up here. So we have a pair of angles there. And remember, you have your reflexive property right here you can use to name that pair of sides. So right there, you should see it. It is angle, side, angle. And then the last one in this section, we have PMK. So notice the order matters. So it starts here, goes to the center, and then goes down the side here. Now without any markings on this one at all, it's very hard to tell, should I start at Q? Oops. Should I start at Q and go to M and then to N, or should I start at N, go to M, and then to Q? So put the markings on there for the information that you're given, and then try to name your order. So the diagonals bisect each other. This is one that we're still kind of hung up on. Remember, bisect means cut in half, cut in 2 equal parts. That's why it says bi. So basically, they bisect each other. So they both are being bisected. So PN is being cut in half right there in the middle. So it's being cut there. So it's cut into 2 equal parts. That side is congruent to that side. And then KQ has been cut in half by the red line. So we have these 2 equal parts. So now we have two equal sides, and you should notice you also have your vertical angles. Whoa, what just happened? I think it got smaller. Let's make it bigger again. Alright, so we have our pair. I don't know why I made two marks. Let's just go with one. Pair of vertical angles. So now you should notice, well, then you have a pair of sides, a pair of angles, a pair of sides. So you should notice it's side, angle, side. So now that we have markings on there, it should be a bit easier to name the order. So once again, we're starting at P because of this order, going to the middle. So that's across the one tick mark. So notice that's across the one tick mark, and then it goes to K, which is across the two tick marks. So to do the same thing, to go across the one tick mark, then the two tick mark, you have to start at N, because that'll take you across the one side tick mark, then across the two. So N, M, Q. So triangle, N, M. Is that a Q back there? Is that a O? That's a Q. N, M, Q. Alright, so for this next section, we have to determine whether or not we have a postulate, because we may or may not, because it says if not, then write not congruent. So if it's not congruent, you shouldn't even have a congruent statement. If it is congruent, then we will have a congruent statement. If you're like, what's a congruent statement? Remember, these are congruent statements, where you're saying one triangle is congruent to another. Alright, so for number 14, it looks like we have a pair of sides. You can kind of see the tick marks there, they're faint. A pair of angles, so I have a pair of sides, a pair of angles, and then I also have my reflexive property I can use to get another side. So that is side, angle, side. And then one congruent statement that we can say is that triangle. Now remember, these could be in different orders, but they just have to make sure they correspond. So I'm going to say RPS. So triangle RPS is congruent to triangle. Now if I started at R, I must say Q first, and then P, and then S. I squish it in there, but so that's my two answers for number 14. Then moving along to number 15, it looks like I have a pair of angles here. I see them. They're already marked, so I don't think I'm marking one, so that's an A. Looks like I have a pair of sides. That's marked. And then I also have vertical angles. I'm going to use two arcs on that. So that's another pair of angles. So it looks like I have angle, angle, side. Remember, it's not angle, side, angle because the S would have to be in the middle, which is this side, and it's not marked. So it's not angle, side, angle. It is angle, angle, side. So angle, angle, side. And I could say that triangle. Remember, this is just one example on the actual congruent statement I'm about to write. Depending on your letters, you could also have a similar one. So let me erase this so I could see it. Alright, so, I probably needed to name it, so I'm going to put this back. Alright, it looks like it has one little tick mark there. Alright, so I'm going to say that GHI is congruent to, so remember, the first way you name it is just however. The second triangle just has to correspond. So G corresponds with J, so that needs to be first. H corresponds with K, so that needs to be second. And then the last letter is I there, so I is in the middle, corresponds to itself. So GHI corresponds to JKI. Alright. And then number 16, so wait, here's my answers for 15. So number 16, we have looks like a pair of angles there. We have a pair of sides there, and we have a reflexive property there. So side, angle, side. So side, angle, side. Then we could say that triangle LON is congruent to triangle. So I went across the blank side, then across the one tick mark side. So blank side to the one tick mark side would be NML. And like I said, your order could be different, but just make sure your letters are in the same corresponding part as mine. So wherever you have L, you also need to have N. So if L is in your middle, then N needs to be in your middle. Wherever you have an O, it needs to correspond with M. Wherever you have your N, it needs to correspond with L. Wherever those spots need to be the same. All right, so number 19. Oh no, we're not all the way to 19, we're at 17. All right, so 17, it's a right angle. So remember, wherever you have one right angle, because a line measures 180 degrees, if you have 90 on one side, then you have 90 on the other, because that's the only way to add up to 180 for any linear pair. So across from that right angle is a hypotenuse, and the hypotenuse is marked, so that's a good thing. That means we could have hypotenuse leg. So we have the H's. Now any other side will could be congruent to give us our L's, because remember HL stands for hypotenuse leg. So we have the H. Now, do we have any other side congruent? So let me erase this so I could see. Well, there's no other side marked congruent, but remember, this side is always congruent to itself when it's together like that. So we actually do have a pair of legs congruent. So we have our H, we have our L, so that is HL. And the congruent statement, once again, can vary. So I'm going to put triangle JGF. JGF is congruent to triangle JGH. JGH. Remember, as long as your letters are in corresponding places, then you're fine. Alright, last one. Well, this one should be very obvious, but some of you guys are still thinking, oh, I see a right angle, it must be hypotenuse leg. No, not all the time. So if the side across from the right angle is not marked, you do not have hypotenuse leg, because that's the hypotenuse and it's not marked. So you do not have HL. So then you look at, what other ones do I have? Well, it has to be one of these A's, S's ones. So we have pair of sides, pair of angles, pair of sides. So you should see pretty easily it's side, angle, side. And then naming it, we have triangle. I'm just going to go with BAC. Seems like a logical order to go that way. Is congruent to triangle EDF. So EDF. Alright. Now we are on to the proofs. So number 19. Alright, so we're given some information. We're given two pieces of information. Remember, the given needs to be in the table. And the reason that you have it is because it was given to you. So what is this? That is something that was given to us. What is this? That is something that was given to us. So far, that fills in the given part. Now, make sure you go through and you mark what was given to you on the triangle if it's not marked already. And then see if you can use any of that information to your advantage. So I'm going to erase that so it's not like all marked up. So let's see if we have everything marked. So YC is congruent to, or Y is congruent to C. Angle Y is congruent to C. That's already marked, so that's good. Then the next piece of given information was that A is the midpoint of YC. So A is the middle of this entire line. So that doesn't give us any markings just already, but we can then say, well, if that's the middle of that line, then this side is congruent to this side. So that's what you need to say next, that YA is congruent to CA. So anytime you're given a midpoint, you should be able to name the two sides of that line. And notice it says the midpoint of YC. It does not say the midpoint of BZ. So you cannot mark those two sides congruent. Alright, so that is definition of midpoint. So they gave us it was a midpoint, so we're probably going to use definition of a midpoint somewhere. Not definition of bisector. I don't see that in the proof anywhere. They didn't tell us there was a bisector. Not definition of perpendicular. There wasn't any perpendicular given. Make sure it makes sense. Alright, so now I have that marked. So right now I have all the markings on my image that I have so far. So right now I have a pair of angles and I have a pair of sides. I need something else. So if we look at these other things that we've been marking, we don't have reflexive property where it's two sides stuck together, but we do have our good old vertical angles. So now you need to name those angles. So remember, you can't just say angle A and angle A. That's not going to work because you can't name it the exact same way if it's two different angles. So the best thing to do is name it with 3 letters. So you have to name angles with 1 or 3. If you can't name it with 1 because there's more than one angle at the letter, then you have to name it with 3. So I'm going to name that top angle, and I'm going to erase this because some of y'all are getting confused with angles. You're giving me sides when I say angles. So we're trying to name this angle right here. Well, what creates that angle? Well, first of all, remember, that's an angle, this is an angle. Angles are kind of like corners. You got to name the start, the middle, and the end of the angle. So if you look at this angle, there's a vertex here. It spans out here and here. So start and end, let's go to Y, go to the middle, let's go to A, and then end on the other side. So Y, A, Z. You could have named it ZAY, but that's the only two names to name that angle. You have to make sure the middle letter is the actual vertex you're at. Has to be the vertex you're at. Alright, so now that is congruent to, now you got to name the other one in the same order. So notice Y is starting at the marked angle. So I'm going to start at the marked angle for the other one. And I'm naming this angle right here. So remember that angle, maybe I should use a different color, is the angle right here. So I'm starting at one end, going to the middle, which is our vertex, and going to the other end. So that's CAB. So angle CAB. Alright. So now, what did we mark? We marked vertical angles. And vertical angles are congruent. I should probably put the word R in there, so let me erase that really quick. Are congruent. Alright, so our last statement. Well, okay, what do we know? So I'm going to erase all these crazy marks I put on here really quick. Okay, it's not dead. Alright, so I'm going to put back what we just need to have on there to make our congruent statement. So I think I had, YA is congruent to CA, and I have my vertical angles. So we have a pair of angles, we have a pair of sides, and we have a pair of angles. So that is angle, side, angle. So a few tips when you're doing these proofs. One, if you're using a definition, it better be of the vocabulary word you're given in the problem. 3 things you're going to look for to mark yourself, if you ever have to mark anything yourself. One is going to be, of course, our well-known vertical angles. All right, another one is going to be the reflexive property, where you can mark a side that's connected to the same exact side in the corresponding triangle. And then our third one that is very common is, let's say we have something like this, and they tell you that 2 sides are parallel. Whenever you have parallel lines, whenever you see them, you know you have alternate interior angles. So those are things you can use. Vertical angles, you can use reflexive property, and you could use alternate interior angles whenever you have parallel lines. You have to have parallel lines. You can't just say, it looks like alternate interior angles. You have to actually know you have parallel lines. Alright, so now let's do 20. So I'm going to flip over here so it's not cut off. Alright, so we know we always kind of start proofs with given, and you're like, there's no given information on number 20. Yes, there is. They gave you information when they marked it for you. So if they marked angle B and angle C congruent, then you need to state that angle B and angle C are congruent. And how do we know that? Because the markings were there. They were given to us. Alright, so another thing. Well, remember that this symbol means parallel. So AC, which is here, is parallel to BD, which is here. They already gave us those. I kind of drew over them a million times, but they already gave us the arrows. Remember, the arrows tell us that those sides are parallel. So they already gave that to us. It was given. Now the next thing, I'm going to erase some of this. Alright. So the next thing it says is that angle CAD. So remember, this is an angle. I'm looking for a vertex, a corner. I'm not looking for a side, folks, not a line. No, we're looking for an angle. An angle. Alright, so the angle CAD. Well, first of all, remember, the middle letter is a letter where you're going to put the mark at. So I know I'm going to put the mark somewhere over here at A. But do I put it on this side or do I put it on this side? That's what the other 2 letters give you. So basically, we're going to make that mark on the CD side. So if you follow it, start here, go to A, and go to D, you should be able to see, oh, that's that corner or that angle right there. And what's that congruent to? That is congruent to BDA. So D has to be in the middle. So I know it's going to be somewhere down here. We just got to figure out which side. So follow the order. And if you go BDA, so starting at B, going to D, and then to A, you should see, okay, that's that corner right there. So we know that those two angles are congruent. So I'm going to erase all that just to put back just the angle marks, because that's a lot of marking on there just for these two angles. So right there, I got to look and say, okay, well, what kind of angles are they? Well, we know we have parallel lines. If we have parallel lines, then we have alternate interior angles. So that's what those are. Those are alternate, or alternating, if you like to put it, interior angles. And alternate interior angles are congruent. So if you even like, you could put are congruent. Alright, so is that enough? Well, let's see. We should have two angle marks because we already have one. So we have a pair of angles, we have another pair of angles. Well, that's not enough markings, because remember, just because you have arrows does not mean it is congruent. So those sides are not congruent. You can't mark the arrows as if they're sides that are congruent. But we have something that we should know from back here. We have pair sides that are connected, so that is our reflexive property. So right here we have the reflexive property, so that is our side that we want. But we marked it, so you have to name it. Anything you mark, you got to name. So we got to name that side AD. That is a side, folks, A to D. That's from here to here. That's what you just marked when you put the little tick mark in the middle. So side AD is congruent to itself, side AD, by the reflexive property. Anything is congruent to itself. Alright, so now we should have enough marking to notice we have a postulate. So we have angle, angle, side. Remember, it's not angle, side, angle because it'd have to be the S there. So it'd be angle, side, angle. It's not. So that's why it is angle, angle, side. So I'm going to put that here before I fill in my congruent statement. So now if I look at the order of what we have, I'm going to put my markings back. So I don't think it was on that side. It's on this side, wasn't it? Alright. So we have A, C, D is the first order. So that is starting here at the 2 angle mark, going down to the 1 angle mark, then to the blank angle. So I'm starting at the 2 angle mark, going to the 1 angle mark, and then to the blank angle. So D, B, A. D, B, A. Alright, and that's it. So now, number 21, we're basically going to try to complete the entire reason side because all that's blank. So let's first see what we're given. We're given that AB is congruent to DC. They already put that in the table for us, and we know the reason why we can put it there is because it's given. Let's also make sure it's marked. So AB is congruent to DC. That's already marked with 1 tick mark, so we're good on that. We don't need to make any new markings. Then number 2 says AC is congruent to AC. Well, they didn't give us that information, but we know if we look at AC, it's congruent to itself by the reflexive property. So that's when we would have marked by the reflexive property. Then, so we need those markings there. Then it tells us that angle ABC and CDA are right angles. So if we look, those are already marked. The right angles are already marked. So we don't need to make any new markings in our image. So now, what reason do we have that those are right angles? Well, because, oops, that was definitely my eraser. They are given to us. Those marks are given. So remember, any marks in the image are also given. All right. And then the next statement says, well, then those angles, those same exact angles I was talking in this one, are congruent. Well, why are those congruent? Well, remember, those little boxes mean they're right angles. Right angles measure 90 degrees. So all right angles measure the same exact degrees. So all right angles are congruent. So now we filled up the proof, so we should have enough to make a postulate. So now, or to use a postulate. So now let's look what we have. Well, first of all, we do have right triangles. So we have a right triangle laying on top of another right triangle. So I'm going to think of, well, could it be hypotenuse leg? Remember, for hypotenuse leg to be the one you're going to use, it has to be the hypotenuse is marked and the any other leg marked. So you're going to find your hypotenuse across from the right angle. The hypotenuse is this side and it is marked. So right now we do have the H for hypotenuse leg. Then leg just means any other leg of the triangle is marked congruent. We do have another pair of legs marked congruent, or another pair of sides marked congruent. So right there we should know we do have hypotenuse leg. Remember, another tip is whenever it says a triangle congruent to another triangle, you should be using one of your 5 postulates: SAS, SSS, angle, angle, side, angle, or HL. So that has to be paired with one of these triangle congruent statements. Alright, last proof. So first let's see what we're given. The given here says RT is congruent to TV. Well, that is what's in the first line, and it was given to us, but what you should notice is it's not marked on the actual triangles. So we need to make sure we mark side RT congruent to side TV. So now we have those congruent. So make sure mark as you go. Alright, now this next thing, the reason says given, so it must be the next piece of given information, which is that ST is congruent to TU. Well, we need to mark that. So ST is here, is congruent to TU, which is here. So we need 2 marks on there because we don't want it to be the same as the other. And that line's too long, so I'm going to fix it because it's going to bother me. Alright, so now the next statement says RTS is congruent to VTU. So first you should notice the T's are both in the middle. So I mean, what other angles are there going to be? The ones in the middle, where T is, those are vertical angles. And vertical angles are, it's a terrible R, but it says R, congruent. It's a terrible congruent symbol, but yeah. Alright, so we have vertical angles are congruent. Right there you should see, well, we have enough to make a postulate. We have side, angle, side. And look what's next, our triangle congruent statement. Remember, whenever you have a triangle congruent statement, you're using one of your 5 postulates. So there's my postulate. Well, what else could they possibly want? Well, now they're saying, well then, angle TSR must be congruent to TUV. So TSR, let's use a different color. Let's use pink. Alright, TSR is, and I'm gonna, so starting at T, going to S, going to R, that's this angle here, is congruent to, that needs 2 angle marks, by the way, TUV. So starting at T, going to U, then going to V, you should notice that's this angle here. Well, how can you say those are congruent? Well, you just said the entire triangle is congruent to the other entire triangle. So because the entire triangle is congruent, all the parts, corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. So remember, whenever it's a statement that's after your triangle congruent statement, it's 9 times out of 10 going to be corresponding parts of congruent triangles are congruent. Alright, last page. So the first thing is, you need to know, if you don't know, hopefully you know, all the way from middle school, is that a triangle's angles, the angles of a triangle add up to 180. Alright, so the angles inside of a triangle. So that would be this angle, and this angle have to add up to 180. Well, right now, those two combined, 124 plus 23, that gives us 147. So right now we have 147 degrees inside of the triangle. We got to figure out, well, how much more do I need to get to 180? So if you subtract, we get, if you do this in a calculator, it'd obviously be quicker. Is that right? Maybe. 33 degrees. So x equals, this angle equals 33 degrees. And since the only thing sitting there is x, then x must equal 33 degrees. So you use the same exact information in 24. Now 24 scares people because oops, I'm on erase, hold on. This expression is here. So I'm going to just scribble it out really quick. Because now, I bet, just like number 23, you can probably tell me what that angle measure is supposed to be. So if we add up these, we get 105. We know the whole triangle has to be 180. So that means that this other unknown angle has to be 75. But guess what? It has a little expression there. Well, what do we know about that expression? We know that expression has to equal 75. So you just set it equal, and you solve it. I don't like how close that is, so I'm going to erase that. And we're going to do a different color. So x plus 83 has to equal 75. So now if you just solve this baby one-step equation by subtracting 83 to both sides, yes, we do get a negative number, folks. We get negative 8, right? Yeah. So the answer is x equals negative 8. Now, it's not the measure of the angle. We know the angle has to measure 75. But if we put negative 8 in there, we will get negative 8 plus 83. We'll get the 75 that angle must measure. So our answer to the actual question, which was to solve for the missing variable, is x equals negative 8. Alright, so moving right along. In number 25, you should notice you have a pair of vertical angles. So that terribly says 65 degrees. Alright, and now you're like, well, how do I find z and x? Well, find a linear pair. If you find where you have a line, you could have used that line or you could have used this line. No matter what, two angles on one side of that line have to add up to 180 degrees because a line is always going to measure 180 degrees. Notice that's a semicircle right there, half of a circle, which measures 180 degrees. Alright, so, oops. If I just use this side over here, I know 180 minus 65 is 115. So z must equal 115. Well, if z equals 115, so does x, because x is right across from or vertical to z. And that's all the angles that we were missing. So now number 26, I'm going to erase this stuff I put down from number 24 so I have room. Erase all of it for you OCD folks. Alright, so number 26. So use what you know. We may not be able to find x right away. Maybe you could if you're really thinking about corresponding angles. But maybe you just say, let me fill in what I know. So we know that's 48. We also know that this is 48. We also know that, so this angle, this angle, this angle, that means this should also be 48. So 4x should equal 48. Now, what does x have to be for it to equal 48? Write an equation. Solve the equation. You have that x should equal 12. And you can make sure it makes sense. If you put 12 in, oh, that is not the eraser. If you put 12 in for x, you'd have 4 times 12. Will that equal the 48 that it's supposed to? Yes, that'll make that angle right there 48, and it is vertical to that one. And that's all we were asked to find, is to find x. Alright, so if that got you lost, let me just slow down a tad bit and just show you which one should all be congruent. So 48 is across from that one, so those are vertical angles. They should measure the same thing. Alright, you should have noticed right away actually that this 48 corresponds to this 48. Notice they're on the same side. It's just kind of like this angle right here was shifted, translated, to the right. So both of those should add up to 48 degrees. Ooh, hit the arrow. Alright, so that's why I was able to say, well, that 4x needs to equal 48, and then I solved it. Alright, number 27. So 27 I would say is pretty challenging, but not that challenging if you think about it, because you can use some information. I see this right angle mark. That doesn't just mean, oh, it's a right angle, that also means it's 90 degrees. So I know the x is down here. I'm trying to find this angle measure, but I notice I also have parallel lines. Whenever I have parallel lines, remember that I have alternate interior angles. So whatever this angle is, that angle has to be 2. So if I find the question mark, then I also found what this angle, undo that, what this angle should equal. So how do I do that? Well, use the fact that you have a triangle right here. It's terrible. I'm writing with my left hand. Well, I am left-handed, so that's no excuse. All right, so we know that a triangle should add up to 180 degrees. So 90 plus 66, right there we have 156. So if I subtract, I get that that question mark has to add up to 24, or has to equal 24. All right, so this angle right here has to be 24 degrees. If that one has to be 24, this angle has to equal 24 degrees. So right there, you should see your equation you have to solve to get x. So we have x plus 8 equals 24. It has to equal 24. So if I subtract 8 from both sides, it's an 8. We get that x is equal to 16. And that's all we're asked to find x equals 16. You can verify that it actually makes sense. If you were to put in, we know that that angle is 24, so I'll leave it. If we put 16 in for x, we'll have 16 plus 8. 16 plus 8 is 24. So that angle does, in fact, equal that angle when x is 16. All right, last but not least, number 28. So we're asked to find x. So if you wanted to use vertical angles, because you all seem to love vertical angles, you can if you like. And if you know that's 130, then that's 130. You could also use corresponding angles. This angle corresponds to this angle. So that's also 130. You could also use same side interior angles. Remember, same side interior angles, that has to add up to 180. So there's several ways to do this problem, but I know you guys just like writing all the vertical angles in, so I'm going to just show that I did that. And then maybe that'll bring you to this line right here. That has to add up to 180 degrees because remember, a line is a straight angle which measures 180 degrees. So basically, we know those two together must add up to 180. So 180 minus 130 is 50. So x has to equal 50 degrees. And since there was no expression besides just x there, you don't have to solve it because it's already just x. So x equals 50 degrees is your answer. All right, hopefully you study. Hopefully you sit here and rewind as many times as you need to, because we don't need to reassess on Unit 2. We need to get it right the first time. Good luck!